Okay, so now we're starting with what's probably the most difficult concept of this entire unit, and that's the surface area of pyramids and cones. It's not difficult because of the shape, it's not difficult because it's surface area, which we've done before. It's difficult because we have to do some calculations to get all the different dimensions that we need. And one of the most important is slant height. So I'm going to highlight this for you, slant height. It's really, really important, and it's different from the height. So if you can see in this cone, this is the height, and that's the height that we used in volume. It's a perpendicular height. It creates a right angle triangle down there at the bottom when you join it to the radius. And that is a really important dimension. As I said, we need it for volume, but it's not the dimension that we really need for surface area. For surface area, we need this dimension here, which is the slant height, which we're going to call S, to differentiate it from the height H. It's not a perpendicular height. It lies at an angle, which is why it's called the slant height, and it's the one that we use for surface area. We don't use H for surface area, we use S. Okay. And you can see on the pyramid, it's the same thing. We have height, H, and slant height, S, and they're different. So let's take a look at an example. We need to calculate the slant height in order to find the surface area of the pyramid. So let's break it down into what we need. Let's think about making this into a net. So if I make this into a net, if I unfold it, it looks like that. And you can see here, this is 10 inches. This is 8 inches. And the height is 6 inches. But we don't really need the actual height. We need to find this height in order to find how tall those, or the size of those triangles. We need the height, like that. And that's S. So let's take a look at how we can do this. So, didn't mean to do that. So if I continue that there, right to the very middle, and I make an imaginary right angle triangle, like that, this is S, and it's going to be the same as that S right there. So this here, I'll highlight that, is going to be 5 inches. Why? Because if I continued it across, it would be 10 inches, which is the length of the base. So what I have is a triangle that looks like this, that's 5 inches, 6 inches, and it's a right angle triangle. So I'm going to use Pythagoras to find it. So remember, Pythagoras says that a squared plus b squared equals c squared. In this case, 6 squared plus 5 squared equals s squared. So s is going to be the square root of 36 plus 25, which is going to be the square root of 61, which is, I'm just going to round to one decimal place here, 7.8. So in order to find the surface area, we know that the base is a rectangle, 10 by 8, so the area is 80 inches squared. And we have two different types of triangles. We have one, which is 8 by 7.8. And we have another one that's going to be 10 by, do we know that one yet? Let's check. That one go like this and would be 6 the height, 4, got slightly different. So this one's going to be the square root of 6 squared plus 4 squared, which is 7.2. So that's 7.2 there. And I have this triangle is 1/2 8 times 7.8. Which is 31.2. This triangle is 1/2 of 10 times 7.2. Which is 36. And how many of them are there? Well, there's 2 of this, there's 2 of this one, and there's 2 of that one. So to get the surface area, we have to add them together. So we're going to have the base plus the triangles, which is 80 plus 2 times 31.2 plus 2 times 36. So 31.2. Add all of that together and you get 214.4 inches squared. So you can see that it's the same concept as doing the surface area of any of our prisms. It's just we have to calculate that slant height. So it's got a couple extra steps, but it really is very similar. Is it the same with cones? Yes, it is the same with cones. Cones are almost easier though, because a cone, when you cut a cone apart, you get this pie-shaped piece and a circle. This is R, this is slant height, and surface area is pi r squared plus pi r s. That's the formula. So once you've calculated the slant height, you just need to plug it into the formula. In this case, they're telling us that that's 7, that's the height, and we need to find the slant height. So we have our right angle triangle. This is 7, this is 3. This is going to be the root of 7 squared plus 3 squared. So S is going to equal 49 plus 9. Square root of the answer is 7.62. So I'm going to have pi, and the radius is 3 squared plus pi times 3 times 7.62. 9 pi plus 22.85 pi. Then we can finish that times pi plus 9 pi gives us 100.05, which is 100.1 millimeters squared. Remembering that surface areas are always squared, not cubed, because they're two-dimensional, not three-dimensional.